in this video we are going to be looking at ester hydrolysis. Now in the previous video we looked at how to make an ester using the process of esterification, where we react together an alcohol with a carboxylic acid. We're now going to be looking at how we break that ester down using this process of hydrolysis. Let's just break down the word hydrolysis so we know exactly what it means. It can be broken down into two. So the hydro part just means water, so being done in the presence of water, and lysis means to break something down. So hydrolysis just means to break something down using water or in the presence of water, and that's what we're going to do with our ester. Our esters, and there are two types of hydrolysis that we need to know, and therefore you need to know what reaction conditions you need for both of them, and also the products that you get from each type of hydrolysis. The first type of hydrolysis that we're going to look at is acid hydrolysis. So this is the one that must be done under acidic conditions. So we start off with our ester. And we usually do this in the presence of an aqueous acid. So that means there is also water present. And in this case, it's the water that's reacting with the ester. So we use aqueous acid, can be any acid. And this also has to be done under reflux conditions, and the products that we get for this are the carboxylic acid, so the parent carboxylic acid, and the alcohol that made it. Okay, so let's just have a look at this using an example. So the ester that I'm going to choose is this one, which is methyl ethanoate. That's going to react with water under aqueous acid conditions. So I'm just going to go for H2SO4, aqueous, and reflux. And let's now have a look at what carboxylic acid made this. So in this case, this part here was the carboxylic acid part. So as you can see, that would be ethanoic acid that would make that. So the parent carboxylic acid, I'll draw it out. Is ethanoic acid. And the alcohol that makes it is this part here. So as you can see, that would just be methanol. Like so. Okay, and as you can see, this water molecule has been added across over here. So that's the hydrogen from the water, and that's the other hydrogen and oxygen from the water as well. So that's how we do acid hydrolysis, and hopefully you can see that this is the reverse of esterification. Okay, so if we do esterification, we're reacting together an alcohol with a carboxylic acid, and we form an ester and water. Okay, so this is technically a reversible reaction. Okay, esterification is reversible to acid hydrolysis of the ester. Okay, right. Let's now have a look at the same ester, but having that undergo alkaline hydrolysis. So alkaline hydrolysis is done in the presence of an alkali. So we usually do it in the presence of a metal hydroxide. And the general equation for this is now ester plus alkali. And the conditions you need for this are reflux. So sorry, I should have written aqueous alkali here. Again, reflux conditions, and in this case we are going to form not the carboxylic acid but the carboxylate salt, and we'll show you why this is the case when we do this example. And you form the alcohol as well. Okay, so let's now have a look at why this is slightly different. In this case, the alkali is not acting as a catalyst as the acid was in the acid hydrolysis. The alkali is actually going to partake in the reaction. So I'm just going to use the same ester as before. So it was methyl ethanoate. Alkali that I'm going to use is, let's just go for sodium hydroxide. Again, aqueous. Need this under reflux conditions. And now we're going to form the carboxylate salt because we've got a sodium ion here. Carboxylate salt is from the carboxylic acid like that. So if we look here, the carboxylate salt, I put my charges in, is that. Okay, so you've got the sodium ion from here, the carboxylate ion from here. Naming carboxylate salt, this is sodium ethanoate, like that. And so we'd used up that part and the sodium, which means we're left over with CH3 and OH, and that's going to form our alcohol, which again is methanol. Okay, so a couple of differences between the two. As you can see, we now get a different product. So even if it's the same ester and we've done the hydrolysis of it, if we do acid hydrolysis, we form the carboxylic acid and the alcohol, whereas if we do the alkaline hydrolysis, we form the carboxylate salt rather than the carboxylic acid. Okay, but we form the alcohol in both of them. This alkaline hydrolysis here, this is an irreversible reaction. So once you form that, you can't go back by changing the condition. So alkaline hydrolysis is irreversible, whereas acid hydrolysis is reversible. Okay. Also just wanted to say that alkaline hydrolysis can sometimes be given a different name. So if you do see it in another textbook or online, it can be called saponification. Okay, so just so you're aware of that as well. But for us in our exam board, alkaline hydrolysis and acid hydrolysis is fine to use.